Hi everyone. So today I'm going to be talking about energy and more specifically about kinetic energy. So energy is a property of matter, just like mass is a property of matter. Whenever something exists, it contains some mass, which in SI system we describe it in kilograms. That thing has some energy as well. Energy can be related to, can have different types. It could be related to things that are moving. Those are basically kinetic energy, and this kinetic, the name should be now familiar to you all. So kinetic is something, it relates to something that's moving. Something that moves, it has some velocity. So we expect that in a format of kinetic energy involves some velocity, and because it's related to matter, it contains mass. So kinetic energy, I maybe, you can denote it by Ke or K itself. It turns out that kinetic energy has this form of a half mass times velocity squared. So be careful that this is velocity squared. So namely, if I want to basically open up this formula a little bit more, I can just write it as two velocities times together, basically. And, this is pretty telling. You see that velocity weighs much more than the mass in kinetic energy, which means that, if I have a kinetic energy of a mass of m and the mass is going by v meters per second, however many meters per second it is, then if I double my velocity with the same mass, if I double my velocity here, because it gets squared, my kinetic energy gets fourfold greater. However, if I have a mass of m that goes with v, if I increase my mass by 2m, but it's still going with velocity of v. So now if I double my mass, I'm essentially doubling my kinetic energy. So see, doubling mass and doubling velocity they don't correspond to the same change in kinetic energy. If you double your velocity, your kinetic energy gets 4 times bigger, and if you double your mass, your kinetic energy gets doubled. So that's why the reason is because it's v squared, but it's only m. So m has a power of 1 and velocity has a power of 2. So velocity weighs much more in terms of kinetic energy. That's basically essentially what kinetic energy, how kinetic energy is defined, and what it means is essentially is the energy that a moving object bears in itself, and it can do something for you. If I throw a rock towards the left, let's say, the rock can maybe hit someone, or it can remove something on its way. So it does something for me, right? So going back to kinetic energy and the fact that it's mv squared, let's figure out what the units for kinetic energy. Units for mass is in kilograms, units for velocity is meters per second, and we have it squared, so we need to square both. It turns out that the units for kinetic energy is kilograms, meters, squared, second, squared. Now, this should look a little bit familiar to you all, because in force, remember what force was? It was kilograms meters per second squared. Here we have an extra factor of meters. So kilograms meters over second squared. And we call this newtons, if you remember. So units for kinetic energy can be either expressed as kilograms meters squared over second squared, or newtons times meters, and we give this guy another nickname. We call this joules. So 1 joule of energy, 1 joule of kinetic energy means that a mass of 2 kilograms goes with 1 meters per second, right? So if I have a mass of 2 kilograms and that mass goes by velocity of 1 meter per second, then the kinetic energy of this mass is a half times 2 times 1 squared, and that gives me 1 joule. So this is, or you can express it as kilograms meters squared per second squared, or you can express it as newtons times meters. So make sure you're comfortable with these, with figuring out the units and all that. But now let's move on with the concept of energy. So before I talked about momentum and the fact that momentum is mass times velocity. Now kinetic energy is also having mass and velocity, but with a different shape and form. Momentum was a vector quantity. However, kinetic energy is a scalar quantity, namely that it's just have some number. It doesn't have any direction to it. And we don't have, if you have some like 20 joules of energy, it doesn't have any direction whatsoever. It's just that number and that's it. The other difference between the two is obviously, so that's a vector. This is a scalar, and also, your velocity here is squared, so this weighs much more than the mass here. Velocity and mass are on the same footing, right? You see, they both come with the first power. So that's that. The other thing, if you recall, we have conservation of momentum in collision problems where we have a closed system where we don't have any external forces on it. We say delta P is F times T. So if F is 0, there is no exerting force on your system. If this is 0, delta P better be 0. And if delta P is 0, it means change in momentum is 0, which means conservation of momentum. Why? Because if you don't change your momentum, that better be conserved number, right? That number of momentum better hold, all right? The same. So delta P, if you open it up, is P2 minus P1. Delta of any quantity is second minus first. And if this is 0, it means that P2 equals P1, and that was conservation of momentum. Now we have the same thing for kinetic energy with one exception. Actually, it's not an exception. It's essentially, no, it's actually not an exception, but I'll let you know what I mean by that. So for collision problems, we have two different collision problems: elastic collisions and inelastic collisions. in all, whichever the collision is, whichever category the collision is, our momentum is always conserved. But the difference comes into play when it's elastic and inelastic, and that's with regards to the kinetic energy. Elastic collisions are the collisions that mostly objects don't get together and don't clump together after they hit each other. They actually go away from each other. It's like billiard balls. When one billiard ball hit another billiard ball, they don't get together and they don't go together, right? Inelastic collisions are actually the other way around. So these are the collisions that when the objects hit each other, they get together and probably they stop. In these guys, no conservation of kinetic energy. But elastic collisions are, the kinetic energy is conserved. So this is the difference between the two categories of collisions, elastic and inelastic. How you get to know it? Well, just figure out the kinetic energy before the collision and figure out the kinetic energy after the collision, and that's very telling. If the numbers are the same, it tells you that's elastic. If the numbers are not the same and some energy is lost in between, then it's inelastic. In the next video, I'll talk about kinetic energy and changes of kinetic energy and its relationship to a work. Bye now.